right. Hello, hello. Hi, everyone. Take your seats. All right, so I'll wait for another 20 seconds. Please find a seat. Finish up your conversations. All right, let's go. So housekeeping. So unfortunately, the kind of last, Charlie 05. Charlie 05. Hello, hi Charlie 05. I don't know your names, but you have a label, so I can call you out. It might not be that embarrassing. I don't know. Okay. So just housekeeping. So if you are on the stream, last time apparently I wasn't actually, because I was sharing two screens, whatever, the code unfortunately did not record. You can look at the Zoom recording from last time anyways. But so in a sec, I'll make myself a little bit quieter. But yeah, if there's a problem with the stream, please let me know on Discord, and we'll try to fix it. It's supposed to be good and it's supposed to make sense. If something doesn't make sense in general, in the class in general as well, please just let me know. We'll try to fix it rather than not fix it. So again, the Discord, so the invite to the Discord, great. So the invite to the Discord is on Piazza. So Technical Q&A is the channel where you should ask questions. If something is unclear, I'll make sure, hi username is taken. So please ask questions and we'll try to check on the Discord. If you want to answer them, you can do that as well. There's a lot of people typing. Okay, all right. Wow. So what I want to do today, and we'll see how far we go, is again kind of just to recap how information is communicated to and from functions. Note so some subtleties about global local. And then if there is time, we'll do a control flow with return. You'll see what that means. It probably doesn't mean anything to you right now. So to recap, what do we have? So what I'll do is I'll go to the notes and just recap what's going on. So this would be this. So basically, again, a function, maybe it does something. So this function, for example, prints the paratified version of a string. So that's referred to as the function having an effect. So that's different from computing something. This is the function, its job is to output something to the screen rather than to return a value. So this is as distinct from this kind of thing, where the function doesn't print anything, it gets a string and it sends a modified string back. Make sense? So the distinction is between a function with a job and a function that just computes something that you can maybe later print. So this is the more usual thing, but in our context, actually, a function with a job does play a role. So what kind of role does it play? Well, so let's say that we want to have something like this. So this would not work. But let's say that we want to do something like this. So we'll name the function plunder grade. So plunder, if you don't know, is when pirates violently steal your stuff. That's called plundering. Okay? So that's the joke. And the idea would be that this doesn't work. So the reason this doesn't work is that first of all, you're trying to make plunder grade be a function with a job. It's not a function that computes anything. Its job, supposedly, is to change the value of the variable grade. Except here, I didn't say global grade. So because of that, by default, grade, if it's defined inside the function, is assumed to be a local variable. So the situation here is that there is a global variable grade, which is 95, and then inside the function, just like before, there is scratch work, and there is a local variable that also happens to be named grade, but those are separate. By default in Python, if you are saying grade equals something or whatever equals something inside a function, grade is a local variable. So it so happens here that there is also a global variable grade, but Python doesn't care about that. If the variable is local, that means that this is just a separate thing from this. So how would you fix this? Well, I can say global grade. So if I say, and I'll change this the way it is in the notes to actually plunder grade. So if I set this to actually plunder grade, then that would work, because if I say global grade in the function, that means that whenever later I say grade equals 0, I mean the global variable grade, so I mean this one. As opposed to some scratch work that's defined inside the function that just exists for the duration of the function. So if I run this now works, so the grade was successfully plundered and now it's 0, is the idea. Right? So you might also have kind of, so let's just expand this example a little bit. So I'll name this pirate treasure, so that's like what the pirates have, right? And I might say, okay, so you can do it with a comma, but I'll just do it global pirate treasure. And I can say, okay, before setting the grade to 0, I'll set pirate treasure to pirate treasure plus grade. And then I plunder the grade. Okay? And then I might do it several times, so maybe someone else's grade is like not as good, maybe it's 87, and we plunder the grade again. And now grade is going to be 0, and if I print pirate treasure, so we'll trace it in a second. So if you get this kind of error, some of the time the reason is you just misspelled the thing. And I think that's probably the situation here. So if I double click on the variable name, you'll see that all the other appearances of that name are highlighted. And this guy is not highlighted because the U is in the wrong place. So that's a way to fix it. And like a lot of the time you get an error. Sometimes it's something substantive, but sometimes it's a typo. So look out for that. So now I run it, and the grade is currently 0, and pirate treasure is currently 182. Make sense? So that's one way in which global variables can be useful. If you have multiple functions that have some kind of effect, the value in the global variable can be used to keep track of something. So if you did the lab already, you know that you could keep track of the current value in the calculator and the previous value in the calculator. If you're doing the lab on Thursday, well, you can look at the handout now, but that's exactly this mechanism, right? So you have multiple functions. Well, here we just have the one, and they all update the one variable. So that is actually useful because, so in here you didn't have to communicate with the function this way, but it's useful in a setting where you have multiple values and it's annoying to kind of pass them back and forth between the different functions. In this case, something like a global variable, once you learn about object-oriented programming, it would be probably an instance variable. If you don't know about that, don't mind me. But if you know about that, well, basically the reason we're using global variables now for this kind of thing is that that's the tool that we have. And actually, it's quite similar to what you would do with instance variables, in the sense that it's doing the same job of keeping track of some information that functions modify all the time. Right? So taking a step back, how am I communicating with the function actually plunder grade? Well, I'm communicating with it via global variables, right? So rather than send it an argument here, and rather than have it receive a parameter, what I'm doing is I'm saying I'll set the grade to something, the pirate treasure is initially set to something, and then actually plunder grade gets information from me by looking at the global variables that I modified, and then it gets information back to me by modifying the global variables. So this is as opposed to the usual way that you would do it. So grade I would get if plundered. Well, that's kind of silly, but whatever. And well, like pirates plunder everything, but so that would be something like this, right? So you would pass it the current grade. Of course, doesn't really need to know your current grade because the answer is always going to be 0. I suppose not necessarily 0, because if you only have late penalties but you haven't submitted anything, maybe you have a negative grade, and the pirates are not going to plunder your negative balance. So maybe we'll do it like if current grade is greater or equal than 0, then we'll return 0. And otherwise, if your current grade is actually negative, then it would return this. Make sense? So the distinction here is if I run this, so let me comment this out. Control R to comment everything out. So if I run this, and then I print grade, who says it's going to be 0? Who says it's going to be 95? It's like one or the other. So who says it's going to be 95? Thank you. Who says it's going to be 0? Okay, it is 95. So why is it 95? Well, it's because what this does is it computes a value. So the value of this would be 0. But I'm not doing anything with that value. And then grade, well, this function never even tried to change grade. Right? So it returned something. It returned maybe 0, maybe it returned current grade, but it didn't try to change the variable grade the way this function does. So that means that, like, of course, grade is still 95. I didn't even try to change it. On the other hand, if I printed this, this is 0. Why is this 0? Well, because let's trace it. We step in. So we can check the value of current grade here. So that's 95. So that means that we'll get to this line. And that means we return 0. So that means that this whole thing just simplifies to 0. So here we're like inside the print, so I can say step out. be a couple times. So here we printed 95. Where am I? So we printed 95, but and grade is 90. In fact, sorry, so we printed 0. This is from this guy. And then we printed 95. So that is from this guy. And now we're done. So I'll just press continue. Let's check the Discord. Okay, nothing in the technical Q&A. Okay, that's interesting. No. Okay, I'll just spare you the messages on Slack and Zoom. So okay, all right. Thank you for the like. Wait. Okay, that was brief. So okay. Oh, it's back. Nice. Okay, all right. Thank you, everyone. So, okay, so usually the way you would set up functions, and this is how you should do it unless I explicitly tell you not to, usually you would do something like this, right? And the reason usually you want to do something like this is that it's easier to keep track of the computation if everything is contained within a function. So here I'm saying something like this, and if I want to use this value, I can. So I can say grade is equal to this or something, but I don't have to, and I don't have to keep track of, oh, did this function change the value of grade or did it not or what? If I know that by default the function doesn't have a job in terms of changing anything, having an effect, it just does a computation, I can then say, okay, it's all self-contained, I can separately look at the function if I want to, and then I'll just use its output if I want to without worrying that it messed up my grade. On the other hand, in some situations, like in the lab you saw, it would be annoying to do things without having a variable that's being modified by multiple functions, just because you have to keep track of like what's currently happening. So this is kind of a silly example of that, but if you're keeping track of like pirate treasure and you're plundering multiple grades, well, like maybe you kind of want a global variable for pirate treasure. Of course, like, you know, pirates didn't have a database actually, and they managed fine. So anyway, that's like that. So let's do a few more examples. So I'll stop doing the funny things, and I'll just name it like change x or something. So if you have a global variable x equals 0, if you want to change it, what you would do is you would say global x, and then you would say, for example, x is equal to 42. So you do change x, and this would be x is now 42. On the other hand, if you don't have a global, then that would not do anything. So you do don't change x, and x would still be 42. So that would also not change x. That's a little bit more complicated. So here you're saying don't change x2. What's going on there? Okay, when do we use return and not use return? So I'll reiterate that in a second. That's a good question. So that would still not change x. Okay. So why would that still not change x? Well, because what you're doing is you're changing this x rather than the global x. You did not say global x there. You couldn't do that anyway. but here you didn't even try. So here x is the local variable 43, which initially has whatever value is here. And the way you would kind of think about it is, well, like, of course, like if this function is like this, it's exactly the same as don't change x2. Because as long as you're consistent, it's all the same. And, well, you might think that this is changing x, but it doesn't, right? So unless you say global something, it definitely is not going to change anything. Because by default, Python treats those as local variables. All right? So you could, of course, do something like this. So you can say, or you can directly say x is equal to 43. That would change x. That's the same example as this one. It's just that you're also passing y to it, not really using it. You're just overwriting it with 43 anyway. But here you say global x, and then you say indirectly x is equal to 43. So that would make x be 43. And it doesn't matter whether it's x or y, right? So you could just say whatever, 1, 2, 3, 4 here. It doesn't matter. So if you say 1, 2, 3, 4 here, what happens is 1, 2, 3, 4 gets sent to the y. So here the local variable y is going to be 1, 2, 3, 4. And then you say, never mind, y is 43 anyway. And then you say x is equal to 43. All right? So the short of it, if you want to modify a global variable, the only way to do it is this. Well, the only way you know of and that you have access to do it is this. You have to say it's global, and then after you say it's global, you say what it's equal to whatever. Okay? So right now with the tools that we have, just nothing else is going to make any difference to the value of the global variable. There's going to be subtleties later on, but for now, that's just true. Make sense? So anything else doesn't matter because it's local variables. So there is a slight subtlety here. So maybe you want to try something like this. So here, what happens is Python refuses to run anything because it's a syntax error. So what's the syntax error? The syntax error is you had a parameter that was named x, and you also said, oh, by x I mean the global x. That makes no sense because this x is definitely local, and then you say, oh, I want a global x by the same name. That's just, there's any number of design choices you could make. Maybe Python could decide, okay, like you say global x, okay, fine, now it's global. But the decision that was made in the design of Python is if here you imply that x is a parameter and then you say, never mind, it's global, you're confused and we shouldn't be letting you run anything, is the decision. Okay, so this produces an error because a parameter x must be local, but later on x is declared as global, and Python just considers this a syntax error. So it's just like, you can't say this. Okay? So another subtlety is you can have a function like this, And this would work. So you do this, and you say print x, and this will print 0. So if a variable is not defined as local, Python will look up the value of the global variable. But again, here, without saying global x, that means that x is local. So there is kind of a little bit of flexibility there, which is arguably unfortunate, which is that if here you don't declare x as local, Python will just say, okay, there's no local x, I'll look up the global one for you. On the other hand, here, if you say x equals 50 without saying global x, well, that means that x is local. So what I suggest doing is, and you won't be doing it much, but you will be doing it in the beginning of the class. It doesn't matter that you can't say print x, just say global x. That would remind you that you're talking about the global variable x. So that's just the same thing. So there was a question on Discord which was, well, how do I use return? So here we were talking about communicating with functions by setting global variables and having the functions set global variables for them. So the default way to communicate with functions is what we did before, right? So something like square of x, return x squared. So this doesn't set any variables at all, right? So here you can just say square of 9 or something, and what happens is 9 gets sent to the local variable x, and the value of this expression would be 81. So the way you communicate information to the function is by sending this 9 as a parameter. The way you get information from the function is whatever it returns, well, that's going to be the value of the highlighted line. So by itself, that's not going to print anything, but the value of this is 81. If you print it, you'll get 81. So this is the usual way that you should go about things. You should send information as a parameter, like this, and whatever information you get back, you should just say, well, the value of this expression, square of 9, that's going to be 81. I can use it however I like. So I can print it, or I can say something like x is equal to square 9, and then I'll print x, or whatever. So that's the same, right? So here, again, I got information from the function by just looking what is the value of square of 9. Well, whatever the function returns, that's the value. So I could, you shouldn't do it in this situation, but I could communicate otherwise, right? So I could say def square bad. So it's going to be ret val square b, and I'll declare a global x. And then I'll just say, okay, so ret val as b is x for as b squared, like this. And then I can say, okay, if I want to compute the square of 9, what would I do? Well, I'll first set x for as b to 9, and then I'll call square bad. So calling means you're using the function. And now I know that the job of this function, that one has an effect. The effect is to set ret val for return value square as b for square bad. to whatever is the square of whatever I sent it via a global variable. So I can now print my 81 like this. Right? So you can see how this is worse. Right? So here I kind of at least took care to name the variables in such a way that probably they're only going to be used in order to send information to the function square bat, because like that's in their name. So the only downside was I have to write 3 lines rather than 2 lines. But it's still annoying to do. If I hadn't taken care to do that and I just named this X, that would be potentially quite unfortunate, because if I mess up and I use X for something else as well, then I call this function square bad and it computes the square of not what I intended to, and it's a mess. So you shouldn't do it. You should do something like this. So the answer to the Discord question of when should you use return, well, usually whatever the function computes should be returned. It's an exceptional situation when you're setting a global variable or you're printing something or something like that. Usually the function would return whatever it computes. So an example of when it makes sense to set a global variable is lab 2. Project 1 would be another example where it does make sense to set a global variable. When does it make sense from a design perspective? Well, when you have multiple functions that all modify the same state, so for example, the current value in a calculator or something like that, then maybe that's the best you can do. Make sense? Questions? All right. What is this about? Okay. If there's any questions, please kind of that were not answered, please paste them again into the Discord so I can see. I can scroll, or like tag me if you want me to answer. I guess is like the other thing. So okay. So the next thing I want to do is what's called control flow. And there's going to be multiple examples of that later on. So that just means controlling which lines of the code are executed. So here's an example. And for now, the examples are going to be slightly silly, but you'll see how this is useful later on. So I'll do my hasRoots function again. And what I might say is, okay, I don't really want to do any work if the discriminant is smaller than 0. I don't want to try to compute like hypothetical roots. So I'll say just right away, if disk is smaller than 0, I can say, well, here I'm not printing anything. I'll just return false. And now, so this is a little bit similar to what we've done before, except instead of doing an elif, I'm just doing an if. True, I guess. So something like this. So of course you could do it more efficiently, but we're doing it this way. So here's how that's going to work. So let's say that I say has roots. So 1 to 1, that does have roots. So I'll put a breakpoint here and I'll run it. So now what's going to happen is I'm stepping into the function. So now if I do one step, I can see A is 1, B is 2, C is 1. So disk is not yet computed, so if I try disk now, that's not computed, but if I go to the next step, now disk is computed. So disk is 0, so that means that I'll skip over this if statement, and now I'm at this if statement, and now disk actually is 0, so I'm in return true. So what this means is that I'll never actually compute disk is greater than 0, because once you get to return true, that's it. The value of this is going to be true. You're not even going to try this. So it's similar to the if-elif structure, which also does exactly the same thing. But here, the way I make sure that I don't try to compute disk is greater than 0 is by saying return. Once you hit a return, you go kind of top to bottom. Once you hit a return, that's it. The value of this is just true. This is not going to matter. So now I'm here. I'm not printing anything, so there's not going to be an output. If I wanted to, I could say print has roots. And that would print true. So to see how this is different from if-elif, what I'll do is I'll say so something like this. I'm always confused about how to type the heart. Okay, so something like this. Just an example, right? So let's see what happens. So what happened is we sent 1 to 1 to has roots. So this has printed. And then it checked, is discriminant smaller than 0? Didn't return false. So now it's at this line, so this printed, and then it checks, is discriminant equals to 0? It is, so the value of that is true, and the function has exited. So for that reason, I take calc, and ESC180 heart did not happen. So because of math, of course, ESC180 heart would never happen, because a number is either smaller than 0, or it's equal to 0, or it's greater than 0. There's no other options. So you would get to one of those return statements. So sometimes, and we'll see examples later on where it makes sense, and hopefully you will remember this. So sometimes it's useful to be able to just say return true and know that nothing else will be printed. Of course, for this particular example, this is not the best design. And there are several reasons for that. So one, a function should either have an effect or compute a value, not both. And here has roots does both. Right? So it prints stuff, and then it also returns a value. That's not considered good design, and I agree with that opinion. The reason it's not considered good design is it's harder to debug. So if the function both has a job and also computes a value, then you need to check both that it has the right effect and also that it returns the right value. You might forget that it does one or the other. That makes it harder to debug. You generally should not do this. So both the effect of change the global variable and the effect of print something to the screen, you can have functions that do that. That's sometimes useful, but it shouldn't be the case that they do both, because that's harder to debug. So mathematically, we know that the function will return something. Because we know that a number is smaller than 0 or equal to 0 or greater than 0. But in general, shouldn't rely on math. It's not trustworthy. And, well, math is trustworthy, it's just that you shouldn't trust yourself to say, oh, math says that it's going to work out, so it's fine. It's preferable, volume down, please. More down, in fact, to 0. Thank you. So a better design might be something like this. So, of course, one answer is just like, don't print stuff. This is weird. So you would compute the discriminant, and then you could just use if-elif. Of course, you could also do greater or equal, but whatever. So this kind of design makes sure that you return true or false. And here you don't need to trust math because it checks two things. So it checks, is this smaller than 0? Is this equal to 0? And then in the else, it's everything else. So that for sure is going to return true or false. Because inside every clause, inside every if and else clause, you're returning a true or false, and there is an else clause. So here you don't need to rely on math, or rather kind of what you think the math is. Python makes sure that you will return true or false. Right? So, and you might say, well, like, what if I want to print stuff? You can. It's probably better to print the stuff in the separate function. So it's usually not a good idea for a function to do two things at the same time, and here it does. So it returns true and false, and then it prints like weird reviews of EngSci courses. Right? So here, like if you insist, so here that would depend on disk.